Thank you very much. First, I would like to start my talk with thanks very much to Professor Jagata for inviting us, and we're very happy that we're going to sign a partnership with the Indian Nuclear Society. I had the pleasure to meet Mr. Malhotra for the first time in 2012 in Paris, because it was just after Fukushima, and I was working for RIAF at the time. And we met all the countries to discuss how we would regain confidence from the public after the accident. And I think that was very fruitful to hear at that time experience from India. We also had, I think, a partnership in 2015 with the Indian Nuclear Society during COP21 in Paris, the conference of parties for the climate conference, where Indian Nuclear Society participated in the Nuclear for Climate initiative, which is an initiative of young volunteers that go every year to represent us at the climate conferences. There were 60 volunteers last week in Dubai, and what they do is that they talk to the delegates, and they are all engineers, and they answer questions the delegates may have about nuclear energy. So they were great. I think there were 1 or 2 representatives from India this year. And in 2015, we even signed, together with the Indian Nuclear Society, a press release during COP to say that we think nuclear should be recognized as a low-carbon source of energy by all the parties in the negotiation. So thank you again. So the French Nuclear Society is the sister to the Indian Nuclear Society. We are the French science organization. We have 3,500 members. And we were created in 1973. So this is a very important date because we are 50 years old, so we just celebrated our 50-year anniversary. And what is a coincidence is that in 1973 was the date, we will just see that, where France launched its big nuclear program, big industrial program. Why? Because in 1973, that was the first oil shock. And 2023 is the year where France is launching again a very big nuclear industrial program. So we are working on it right now, and I'll share with you a little bit what we're doing. So, thank you very much.
Forward, backward on this.
Yes, thank you. So, a little bit of history back. So you see, as I said, do I have it? No. Okay, so I'll show you without the light. So 1973, that you see on the chart, in 1973, France was getting 70% of its electricity from fossil fuels. Actually, when the first oil shock arrived in 1973, the biggest oil consumer in France was EDF. And in 20 years, we built 58 units. So that was quite an achievement. I think the country that went faster than us was Sweden, but we built 58 units. And you see that we went from 70% of our electricity based on fossil fuel to less than 10% in 20 years. And by the meantime, we more than doubled our consumption of electricity. So that shows that this can be done, provided that we have the industrial organization to do it, as well as the political will, which was really what we had at that time. So today, 70% of our electricity comes from nuclear in France, and 90% of our electricity is decarbonized. Actually, it's less than 50 grams per kilowatt hour on an average per year. So it's pretty good. We are one of the only countries in Europe and in the world who have nearly decarbonized our grid. Together with, in Europe, we have Norway with a lot of hydro, but otherwise we have Sweden and Switzerland, and they both combine hydroelectricity and nuclear. So you see on the right, so right now we have 56 units operating on about 18 sites. We have Flamanville that we expect to load the fuel early 2024. We are finishing right now the hot testing. And we have, as I will say, what you see on this map is that we not only have nuclear plants, we have also a big industrial sector behind it with 3,000 companies. And we have about 220,000 employees working in the nuclear industry. It's the third industrial sector in the country behind aerospace and automotive industries. So in red, I anticipate a little bit what I'm going to see. In dark red, to see the 3 sites that have been chosen to build 6 EPRs, which is a part of the industrial revival that I'm talking about. So this industrial revival, we don't only see it in the world, we see it in Europe. Europe, which used to be very influenced by anti-nuclear groups, is now going back to nuclear as a continent. We still are the biggest area in the world for nuclear. We have more than 100 nuclear plants right now. Nuclear reactors, sorry, so we're bigger than the United States, but of course we are this among several countries. And in May last year, under the leadership of a French energy minister, there was a signed alliance between 14 countries plus the UK, so 15 countries in Europe to agree on a 150 gigawatt target by 2050. That means building around between 30 and 40 large-scale reactors by 2050. So this is really new for us. And every day we have news from a country announcing a program. The latest was really Sweden, who announced a program for 10 new reactors. And we also had last week a vote from the Council, the European Council, to set nuclear as a strategic net zero industry in Europe. So lots of progress is being made. So last week in Dubai, as I said, we had 60 volunteers, and we measured the progress made since the Paris COP in 2015, because we had heads of state, so about 22, who declared that, pledged that we should multiply by 3 the nuclear capacity by 2050. So this is really the first time ever it happens. I've been to all the climate conferences since 2015, and honestly, this is a major, major change. So first, where does it come from, this tripling? So there is a science behind it. It's very important. So first, this tripling of capacity comes from the IPCC report from 2018, which is the 1.5 degree report. And they did 90 scenarios of decarbonization by 2050. And the average capacity out of these scenarios was actually a tripling of capacity. So this is the data from a report from 2022 from OECD and EA, when they looked at how can we achieve this capacity. So you see in dark blue, you see a lot of contribution from long-term operations of nuclear plant. You see in light green the large-scale reactor, and you see also the small reactors. So you see there are two projections, a conservative one and an ambitious one. So what they said is this is basically to reach the objectives, we need to combine, long-term operations, large-scale reactors, new large-scale reactors, small modular reactors, as well as innovation, that means beyond electricity, that means having nuclear produce hydrogen or heat, go beyond electricity. So that's exactly the strategy for France. So the strategy is based on 4 programs. So the first program on the left is a long-term operations of our plants. So we have 58 units. Right now, the first ones have been authorized to go beyond 40 years. We have a generic agreement with the safety authority to go to 50 years, but now we have to get approval for every plant, and we're doing some major investment. To give you an idea, we're investing nearly 1 billion per unit. So this is the biggest program in the world. Why? It's because of safety authority has asked that we try to reach the objective, the safety objective of a Gen 3 reactor with our Gen 2 fleet. So we are making a lot of safety improvements, not only component replacement, but we do safety improvements on our plants. We hope that, of course, that will go to 60 years. And we hope, based on the examples from the US, that we'll be able to go beyond 60 years. But today, this has not been confirmed by our safety authority. They haven't defined yet, together with EDF, our operator, what would be required in terms of work on the plants to go beyond 60 years. The two things that we're going to see in a 50-year, to go to 60 years, are, of course, conformity to the initial design, but also adaptation. We have lots of questions in general from the public on adaptation to the plants, especially for the plants that are on river. We have lots of questions about water consumption, for instance, so we work a lot on that. The second program is to build large-scale PWRs, so we have chosen the EPR to do it. So right now we have a law which is going to Parliament early 2024 to build 3 pairs, so 6 units. So why 6 units? Is that first, when we build a pair, we make savings of 15% on the cost. And if we build 6 units, and we launch 6 units, we believe we can reach 30% of cost reduction. That's why we want a series of 6 units. But there's also discussion about 8 additional units by 2050. That means 14 units starting to be online in 2035. That means that we have to keep the pace of 1 unit per year after 2035. Third program is a light water, so PWR, SMR program called New World. So New World is a countrywide initiative. It's supported by the French government with a 500 million euros grant. And it's 2 times 170 megawatt PWR. So it's an island of various companies who have bringing really knowledge. So we have Technic Atom, who is responsible in France for submarine propulsion engines. So they have a lot of experience in designing compact and SSS. We have Naval Group, who is in charge of building the warships. And so they have a good experience in modular construction. So that's really where they're bringing a lot of value. We also have Electrabel. So on New World, we have an objective to go for first concrete in 2030 in France for a first pair. And we also, we are writing a paper right now because we are consulted as a nuclear society into the new law. We're asking for a second pair because we want to start building series effect, and also we want to start to see what are the challenges in going to new sites. Because something I didn't say is that the EPRs are going to be on existing sites. But we want with the New World to try to go to new sites. So for instance, existing coal sites or big industrial sites where there's a need for electricity and heat. So what's important for us, because people are asking us, so why are you building and investing on SMRs if you have this program for large scale, is that really for us, the large scale program is for energy security. We will need a lot of electricity. We think our electricity consumption will increase by about 35% by 2050. Some say it's going to be higher than that. First, because of electrification. We're going to go from 25% of electricity in our energy mix to about 50%, but also because we want to go back to a big industrial sector in France. And the EPRs are here for security of supply of electricity, together with the fleet, the existing fleet, the long-term operation. This is our strategy for ensuring electricity security on the existing site. And the SMR in our strategy is really to try to go into new applications, strengthen the network for sites, industrial sites that have a lot of electricity consumption, but also to provide additional services. So that's what I'm going to talk about. So last but not least, the government has done a request for proposal for disruptive innovation. So of course we're thinking about Gen 4, but it's also smaller, very innovative reactors. So they have made a grant of 500 million euros to attract private investment. And we were really surprised because we have 15 companies that were created to answer this proposal. And so far, 8 of them have been granted support, and we're still expecting some new announcements. So we call them advanced modular reactors. So we have 4 programs. So it's pretty heavy for the French industry. And because we not only have these 4 programs, but we also have, in parallel, the deep geological repository, where right now we are in instruction with the safety authority to get the authorization for it. We also have some expected investment on the fuel cycle side. So our conversion plant is new, it's very recent, just open. We have also a new enrichment plant, but we're going to expand by 1/3 our current enrichment plant, GB2. But we also believe we should renew our back-end plants, La Hague and Melox, that are reprocessing the used fuel and also making the MOX fuel before 2040. So we have to prepare and start working on it now. And last but not least, of course, we need to reinforce our research facilities to be able to support this program. So we have a lot on our plate. So I said that we were today 220,000 people working on nuclear in France. So based on the industry work, they have done a study. We need to hire 100,000 people in the next 10 years. So that's small for India, but that's quite big for us. So right now, all the industrial sector is looking for engineers, and not only engineers, but also technical workers, because we need a lot of talents, right? So I was talking about an Italian organization, because Italy, they have a lot of engineers and really good engineers, but they don't yet have a nuclear program. So we have about 150 of them that are working in France right now. So we say, yeah, great, we need you. And then, of course, then you'll go to work back in Italy when Italy starts a nuclear program. So I think EDF tomorrow has presentations about the EPR, of course, and about new ones. So I'm going to focus more on the innovation side. So of course, because the talk is on innovation, we have innovation on every program. We have a lot of innovation on the long-term operation program, in materials research. I think the 2 areas where there's the most innovation required right now is really materials, aging, for instance, for LTO, but also for digital transformation. We're using a lot of digital technology now for every program, and that's also a way to attract the best talents, because the best talents, we really like to work with the best tools. We just recently had a conference on how we use artificial intelligence in nuclear, for instance, for predictive maintenance. So we're really trying to build a lot of innovation on every program. I'll let EDF tomorrow to talk to you about what kind of innovation we have on the PWR, but there's a lot going on right now as well. So I'm going to focus on the toolbox two boxes on the right. So before I do that, since we just made the decision to go on a big program, I'd like to share this research because I think it's very good research that was done 2 years ago by our network operator. Because they were asked by the government at that time to say, should we build more nuclear reactors now or should we go to renewables? Because a lot of renewable industry saying, oh, we're cheaper than nuclear, so we should abandon nuclear, we keep the existing plants and we don't build again. So I'm going to show you this research because I think it's very important. So what they did is actually 6 scenarios. So each line is one scenario to reach net zero by 2050. So they did 3 scenarios with no nuclear in 2050, and 3 scenarios with different level of new construction, which are around the 3 ones on the right. And what you're seeing here is annual cost of a total electricity system. The total investment is about 1,000 billion euros over 30 years, right? And it's what you're seeing is the average cost of 30 years. So the green part is the cost of the renewables, and the yellow part is the cost of nuclear in the electricity system. So what you actually see is that when you add nuclear and renewable, the cost of production itself is the same in all the scenarios. That's not what makes the difference. What makes the difference is the orange. So orange is the means of flexibility you need to put in a system to compensate for the intermittency of renewables. Of course, the more renewables you have, the higher the flexibility cost. And then the top 2 colors are the transport of electricity, the grid, and the distribution of electricity. And what you can see is that these orange and the flexibility, the transmission and distribution, that's really what makes the difference. So what we call that is systems cost. So the higher the share of renewables, intermittent renewables in the system, the higher the systems cost. So that's really what makes the difference. And the difference for France was 10 billion per year. So this was used in the debate to decide that we should build new reactors. That if we build new reactors, we lower the cost of the electricity system as a whole. The second thing we did was look at the risk associated with each scenarios. So the risk associated with the 100% renewable scenarios were twofold. The first one is our ability to deploy renewable fast enough, which is an industrial challenge, but also a public acceptance challenge, because right now we have lots of public debate about especially wind, terrestrial wind. So it's not easy to deploy wind farms today in France. It's complicated. And there was a risk associated with the grid as well, because it's also difficult to create new high voltage lines in France today. The public doesn't like them. And the third risk was the flexibility technologies, because most of them are not available today at industrial scale, so we couldn't bet the future of the energy supply of the country on technologies that are not proven. Okay. So that's why we decided to go. Of course, there were risks associated with the nuclear scenarios, and the main risk is whether we're able to build these nuclear plants fast enough. Okay, so that's what was the reason behind it. So what I want to say is that it's very important that we explain that, because we have lots of people say, oh, nuclear is too expensive. Well, nuclear, you know, we try to use series effect and to be industrially efficient so that it's as cheaper possible. But it's not only a matter of cost of production for nuclear, it's also a matter of grid. It's very important. Okay, so this is the first set I wanted to show you, because for us it's a big change. As I said, right now the nuclear fleet is 100% electricity, produces a lot of electricity. We actually export a lot of electricity to our neighbors. We export 10% of our production, which really helps our neighbor to lower their consumption of fossil fuel, of gas and coal, because some countries like Italy rely a lot on the French nuclear fleet. But the new thing with New World, with the first SMR, is that we're able to go beyond electricity. And it's going to be new for us. So there are several areas we're looking at. So of course we're looking at high temperature electrolysis. It's able to really hybrid electricity and heat to have more efficiency in the electrolysis of hydrogen. And this hydrogen, we plan to use it mostly in the industry. Our industry is already consuming a lot of hydrogen in several sectors, but we also want to use hydrogen, for instance, to decarbonize the steel. We want to use heat for district heating. And we also want to use heat to decarbonize industry with high temperature reactors. So a lot of innovation that we see coming. So it's not only innovation, technical innovation, it's also a lot of regulatory changes, a lot of new business models, because right now we have never supplied heat to urban networks. I think it's done in about 40 cases in the world, including in Switzerland, so very close to France. But it's going to be a major policy change, and we have to put together the whole ecosystem around it. Let me move to really the innovative reactors. So right now, IAEA identifies 70 concepts of SMR, advanced modular reactors in the world. We believe there are more because the 15 French ones are not in the system yet. So it's going, it's a very, very strong effervescence of innovation, lots of new ideas. So that's how we see because we have now 15 companies, so we map them along this map. We map them on one side with what we believe are mature technologies. So mature, that means that we already had a functioning facility. So of course, we are very invested in sodium fast reactors in France. So we have right now 3 companies that are spin-offs from CEA that have proposed new models for sodium fast reactors. The high temperature reactor, we also have one startup that have just received a grant on high temperature reactors, so we call that the mature technologies. Though there's a lot of innovation going on in the concepts that the companies are building. The lower maturity, so we have one company that has received a grant for lead. And we also have 3 companies that are proposed a molten salt reactor. So the molten salt reactors technology we're going to use in France is mostly chloride and plutonium based, because we have plutonium. And also chloride salts are compatible with our current industrial facilities, mostly La Hague, the La Hague processing plant. And finally, we have 2 startups that are presenting fusion projects. So you see that we have a whole portfolio of technologies that are very interesting to look at. And as I said, we've been really surprised to see how much innovation there was. And those companies are attracting talent from the best universities in France, and as well as from abroad. So we're really happy about our ability to attract talent on these projects. So what we expect as benefits from these companies, so we expect some decarbonization benefits, especially from the high temperature reactors, because to decarbonize some industry processes, there is no other choice right now. There's no competition. So some say, yes, we could use biomass, but biomass resources in France are very limited, and people say we should protect the forest more and more. We have competition with agriculture, so we expect a lot from these reactors to decarbonize some of the industrial sectors. And actually, these sectors show a lot of interest right now for these technologies. Because, you know, we just went through a major energy crisis on gas in Europe, and some of these industries are not competitive anymore because of the high prices of gas in Europe. And it's either, you know, they have a solution to remain and produce in a competitive manner in Europe, or they will go away in regions where gas prices are lower. So it's become really a very important strategic initiative for us to be able to keep our current industries and attract new ones. The second benefit we expect is to be able to have new regulations on safety, to be able to put, because of the very interesting safety concept that each of these technologies is bringing, to be able to get closer to industrial sites and to new sites, as I mentioned, which is a very important topic for us. On the fuel cycle side, it's very important. Why? It's because, as you know, we have a strategy to close the fuel cycle. And also we have a lot of stocks. We have, of course, plutonium from the reprocessing of fused fuel, so we want to use our plutonium. We have a lot of depleted uranium that are the tails of our enrichment facilities. So we want to use these great materials to be able to power the new fleet. And with these technologies, we can do multiple recycling. For instance, right now we have a used MOX. And so we're looking at several options to recycle the used MOX. And so these technologies allow the recycling of used MOX. Some of these technologies can even recycle americium, which would be interesting because even if we have a strategy with deep geological repositories, being able to get rid of the actinides in the final waste would make the final life of this radioactive waste shorter. And we believe the public would be it's good value proposition for the public. Because the number one thing they usually say when we ask them, what do you like with nuclear, they say energy independence. Because most of them don't know, half of them don't know that we're low carbon. And we ask them, what is it that you don't like with nuclear? They say waste. So we think it's a good value proposition. That's it. So I wanted to invite you to one of our technical conferences, because every year we have these big international conferences that we host. So last year we had 3 of them. We had the big NPC, the Nuclear Plant Chemistry Conference. We had the big nuclear engineering conference, civil engineering conference. We also had PATRAM, which is the fuel transportation conference. But next year we have 2 subjects that we're going to cover. So dismantling, maybe it's too early for India, which will be in May in Avignon, in the south of France. And we also have the SNA, which is a joint international conference for supercomputing in nuclear applications, and Monte Carlo codes, which will be in October in Paris. So I think we're about to send the call for papers, but we will be very happy that you could join this conference. Thank you very much.